Hi class, today we're going to be talking about 2-3 tables and expressions. So let's start off with example 1. We have both my brothers. We have Curtis, who's older, and we have David. Now they're older than me, so obviously this is a while ago, but their ages, let's say, are 9, 10, 11, 12, and I'm going to put an n down here. Now remember that the n can represent any number possible, any number that we may think of, and that can be Curtis at any age. Now when Curtis was 9, David was 12, and a lot of times students want to write 16 down here, but because we don't know what n is, we can't fill this in. This is our expression that we're looking for. Remember, an expression has 3 things. Number 1, it has a variable. Number 2, it has an operation. And number 3, it has a constant. And constants are usually just numbers. It's something that can't change. Now let's take a look at this table. We're not looking for a relationship between Curtis's age because that's just going up year by year. On February 8th, every birthday that he has, he gets a year older. What we want to look for is the relationship between Curtis's age and David's age. So take a second and try to figure out the relationship from this column to this column. If you guess +3, you are correct. So David is 3 years older than Curtis. Now, because there's an n here and we don't know, we can't just assume, again, that it's going to be 16. We have to assume whatever n is, that David will be 3 years older. So there's your expression, n plus 3. Next, let's take a look at example 2. When we go to a store and we buy eggs, they always are sold in dozens. So let's write in the number of eggs that we can buy in each dozen here. And we'll put an e at the end to represent any number of eggs that we could possibly come up with. Now let's fill in the dozens. Now again, a lot of students are going to want to fill this in with a 5 right here, but we don't know that this is 60. We cannot assume that we know how many eggs are here. If there's nothing here, we cannot put anything here until we find the relationship. Remember, you're not looking for a pattern here. Not within the terms here. You're looking from one column to the next. You're looking for 2 different labels. I'll give you a moment to see if you can figure out the pattern. If you guessed divided by 12, you are correct. And to get our expression, our algebraic expression, our variable, use the same operation, and our constant. Notice how we went from 12 to 1. There's only 2 ways to get there. We can either divide or we can subtract. But seeing as how we found a constant pattern, that's our expression. Now we have our third and final example of the day. Now keep in mind, sometimes tables are positioned this way, where they go across rather than down. The position just tells me where it lies in our pattern. And remember, a term is just one value of a sequence. So again, here's n. Don't assume that it's going to be 6 and this is going to be 13. We don't know what n represents yet, so don't fill it in. Whatever we put here has to work for any number that we could possibly replace n with. So we're looking for patterns. This is what we call a guess and check method. We want a relationship not 3 to 5 to 7, because I can see it goes up by 2s. I want to know a relationship from one label to the next, from this position to the term, from 2 to 5, 3 to 7, 4 to 9, 5 to 11, and whatever n is to whatever would go here. So let's start out with some possibilities. Well, we see it goes from 1 to 3, so we know it's going up or getting larger in value. There are two ways in which something can go up. We can either add or we can multiply. If we're going to add, to go from 1 to 3, we'd have to add 2. From 2 to 5, we had to add 3. 3 to 7, we would add 4, and so on. Notice that it's not the exact same number that we're increasing by, so adding won't work. Then we go to multiplying. To go from 1 to 3, we'd multiply by 3, and we'd have to see if it would work for the next one. To go from 2 to 5, we can't use a whole number anyway, so we notice that multiplying by 3 doesn't work. This is where you might have to get creative. Sometimes you just have to get close to the number with multiplying and then add or subtract to see if you can get to the actual number. So, how can I get close to 3? I can either multiply by 2 or multiply by 4. We saw that 3 doesn't work because it gives us the exact number here, but it doesn't work for the next one. So let's take a look here, and we'll start with multiplying by 4. Well, if I multiply 1 times 4, that would give me 4, and then I'd have to subtract 1 to give me 3. Okay, that works. Now let's try the next pattern here. I'd have to say 2 times 4 equals 8, and then I'd have to subtract 1. I'm looking to get 5. Well, it doesn't give me 5, it actually gives me 7, so we notice that that actually doesn't work either. Let's go back up here to the 2. If I multiply 1 times 2, that gives me 2, and I would have to add 1 more to give me 3. So it works for the first one. Let's try the next one. 2 times 2 equals 4. If I add 1 more, that does give me 5. Seems to work for this one. Let's try here. 3 times 2 equals 6. If I add 1 more, I do get my 7. So I notice a pattern is developing. So no matter what these numbers are, whatever it is, I'll be able to say n times 2 because that's what my pattern shows. I multiplied by 2 each time. And I need to add 1 to get to the number. There is my expression. The guess and check method will be extremely helpful, especially when you notice that simple adding or simple subtracting or multiplying or dividing doesn't seem to work. You're going to have to get creative. Thanks for watching. Now what your assignment's going to be. Now for your assignment. What I'd like you to do is on page 60, I'd like you to do problems 2, 4, and 6, making a table just like we did in our examples. Make sure to put these at the bottom of your notes because I'll be checking. Have a great day.